If you watched my previous video on the topic, you'll know the only sound hardware the first PCs came with was a speaker that could beep. Today, we're going back to 1987 when a company called Covox released a device that could reproduce audio. They called it the Covox speech thing. So I'm going to be writing code to play audio out of one of these devices and then actually build one myself. This video is sponsored by Brilliant. More on that later. Today, we totally take this for granted, that our computers can play high quality audio, and it's been this way for over 30 years. Like most technology, what was once fascinating and clever has become mundane and sort of expected. Well, today we're going back to 1987 when a company called Covox released a device that could reproduce audio, and it didn't need the user to open their PC. They called it the Covox speech thing. This is not a video about the history of the Covox speech thing, or its variant, the Disney sound source. People far better at telling history stories have done that. Go watch their videos after this one. No, what we do here is write code and figure out how things work, what's actually going on inside these little boxes. So I'm going to be writing code to play audio out of one of these devices and then actually build one myself. Turns out the hardware is incredibly simple. And I find that simplicity really fascinating, that a few bits of electronics that really don't do much that I can build is somehow capable of making audio that sounds okay. Here's the plan. A bit of thinking had me reasoning that playing sound out the printer port is no more difficult than playing noise out of a PC speaker. We have our sound, we have the printer port, and it's available as a port in software that we can just write bytes out of. So if I make an 8 kHz uncompressed mono WAV file, like I did before, I can just shovel that out the printer port 8,000 times a second, and there we go. Well, that's the idea anyway. And it turns out that 86box can emulate the hardware, so I can test it even works. For the hardware, I've got this PC, and the circuitry required is only a few resistors and a connector. I should be able to get the PC to play the sound. Well, that's the plan anyway. If you're a regular here, you should have figured out I like programming. I like getting lost down rabbit holes and figuring out precisely why something works. I don't care if the knowledge is 30 years out of date. The process of working it out is fun. So let's go to me trying to make this code work. I've got a feeling that the code that I'll be using will be very similar to the code that beeps the PC speaker. I think it's almost the same. I'm just not sending data out the speaker. I'm instead just sending data out the printer port instead. So I should be able to modify the code I've got here, but I'm going to start with a new file, and then I'm going to see if I can get this working with like a basic idea. Okay, I was just trying to save a file, and I guess I can't call it lpt1.c. Is that too close to an actual sort of fake DOS file name? I don't know. Let's try a different name. Right, I've got a second screen with some notes on. So I'm going to see if I can make this at least make a noise. It may not make what I want, but I'm just going to see if I can make a noise of some description. It would help if we had more brackets in there. Okay, will this make a noise or will it not? Made something. Made a horrible screechy noise. Can we make a lower pitch screechy noise? We can. Ooh, it made it beep like a PC speaker. Okay, as a proof of concept, this is working. Those beeps you're hearing are not coming out the PC speaker, they're coming out the printer port to a fake audio board. The code is really, really dumb. It couldn't get any dumber. All this code is doing is making a for loop that runs 1600 times because we're going for an 8 kilohertz sample. So that should be about 2 seconds of sound, which explains why the delay wasn't working before. I misunderstood what that was doing. We're then dividing the value by some number that I discovered just that sounds better than the high-pitched screech that it was making, modded by 2, so that we're making a really nasty square wave that is sort of that frequency. And then we shove that out the printer port, it goes through the special piece of hardware, we get sound out the other end. So if I want it to be longer, I guess I'd change that 2 to a 3. Okay, whatever. There's limits to how big the numbers can be, because it's an unsigned integer. Don't care. It beeps. Let's move on to something that sounds better. Right, this will make some of you twitch. Yes, I'm trolling some of you. I use this to kind of help me get the idea, just check I was thinking the right way. So, you know, I'm like, I've got Boolean C++, blah, 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 blah. What's the minimum code? It gave me the first bit of code. That was nice. It tested, it worked. Then it's like, oh, here's better code because you want to use a timer interrupt. I was like, cool, yeah, right, fair enough. And I tried it, and it just made a hideous, awful farting sound. Well, it wasn't wrong. That was a horrid noise. And then I'm like, it don't work, and it's this bit here. Yes, that's what I expected. Well, why did you write that code for me if you knew that that was going to be wrong? What are you doing? You really can't trust this stuff. You've actually got to turn your brain on. Okay, so this is the code that will play a pretty noise out of the speaker attached to the printer port. I'll show you, well, I can't show you, can I? You can listen to that in a minute. Let's just go through the code first. So we do some hash defines. Look, there's a frequency of the timer, sample rate. Similar stuff to last time. Look, we've got an interrupt for the old one. There's some basic maths. I want a 220 Hz tone. I don't want an A because it's too high pitched. You complained in the last video that it was high pitched and awful. I agree. I did try to fix the volume, but I guess I didn't fix it enough, so I'll try harder this time. So we're making a table, put the wave in. This is our new interrupt service routine. So we're going to just spit the bytes of that wave table out of the port, wrapping when it runs out so it doesn't stop. This bit here is extra. What this is doing is ensuring that the BIOS keeps ticking along as well, because the BIOS is really using this interrupt to make DOS work. Or DOS is using it. Something deep within the innards of the operating system needs this to keep its sanity. But it needs to tick at the right speed, so that's what this bit does. And then we call that, which I've forgotten why that's there. Here's the main loop. We're setting up the divisor, the value that the thing should run at. Then we're creating our little table of values that is the sample that we're going to send out. We're then setting up the interrupt vector and then setting up the timer. We're then making the horrid noise. It just begins. So we can do something else with our program whilst the horrid noise is happening. And then we turn it all off and reset it back to how it was. So this is what it sounds like. Again, if you have headphones, turn them down or take them off and just hold it awkwardly like a kid holding a modern mobile phone. So if you listen to my warning and you turn your speakers down and you're not deaf and you can still hear me, we are now going to try and play something a little bit better out of the sound device that we're emulating. Let's try and play a WAV file, because it should just be a case of, instead of generating a wave and putting it in this wave table, we read a WAV file in and play that instead. And it should sound better than last time's PC speaker crunchy weirdness. So let's give it a go. What you're looking at here is the code from before to play a WAV. Most of it is the same as before, so I think if I just copy and paste bits of this and merge it with what I had just now, I should be able to play a WAV, and it shouldn't be too painful because all the awkwardness was worked out last time. We'll see if we can make it play a bit of last time's video. So let's give this a go. It compiled first time. I'm very suspicious. Let's run it and find out what happens. Oh wait, this loads in too much memory. Yeah, this loads too much. I need to compile it and then quit and run it separately. I won't. Cool, divide error. Okay. Welcome to DOS development, where you crash your computer and you have to reboot it. Quite a lot. Right, what we're trying to load anyway, because that's probably half the problem. I understand why it crashed. Yes. Yeah, so if we go into the file that we were trying to use as our example, you see that line of code there? Do you think it's important? Do you think I should probably have that in mind as well? Like, maybe I need that about there. Right, let's try it again. Maybe it'll work this time.
Now then, what if I told you not all bleepy noise is the same? That it's possible to play back better noise that sounds far, far better than it. Now then, what if I told you not...
It works! That's really cool. Let's play back some other noises. Making all this code work was surprisingly manageable. I built on skills I'd learnt previously when I was making those awful noises at the PC speaker. And since I started learning to code as a kid, I've somehow kept up that as a regular habit. So I've been able to learn and improve my skills over time. And building on previous skills by creating a daily habit is something this video sponsor Brilliant also encourages. Because if you practice a bit every day, it adds up. It's not just programming though. Brilliant has visual interactive lessons on maths, science, data analysis and AI. You might have noticed I spend a lot of time in my videos explaining how and why things work the way they do. This is really important. Memorizing information only gets you so far. Brilliant structured lessons build not only on real knowledge on specific topics, but they also help you become a better thinker. It only works if you do it regularly, however. But our time is limited. Everyone is really busy. But something I personally like is each lesson on Brilliant is short. I've got the phone app and it'll ping me a reminder to do some learning. And if I get stuck, there's explanations too. To learn free on Brilliant, go to brilliant.org/ncoptechnology or scan the QR code on screen or click the link in the description. Brilliant's also given our viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Let's be honest, doing everything inside an emulator might be convenient, but it doesn't have the same visual appeal as using the real hardware does. It's also about 10% as interesting, especially to me. Especially when trying to make sound with a piece of hardware. If I just emulate the hardware, have I really used it, or is it just playing out my PC? Anyway, while digging around in our loft, I came across this ancient artifact and decided it'd be something I could use. In fact, I'm going to pick the thing up and show it to you. Let me just unplug all the wires. It is a compact Presario, something or other. It's got a Pentium inside it. It's got built-in audio, so it doesn't really need this thing that I'm building, but that's half the fun. I figured that all this needed was a compact flash adapter, a bit of a clean, and maybe a Gotek. And then I could just install Windows on this thing again, because it's got its ancient hard drive that sounds a bit funny. And I figured I could use this as like the development machine instead of having to use an emulator on my PC. But that kind of went really, really wrong. If you want to see the farce involved in making this work, I'm going to put some edited highlights up now, but the full version of this will appear on my second channel some point soon when I've recovered from just the frustration of trying to make this thing work. Right, so I've got this computer that I want to use. It's a Pentium something, compact Presario 4108. And I thought it'd be fun to use this for my DOS videos because, you know, then I'm coding on a real PC and not just an emulator on my PC. Right, so here's the first thing. So this computer setup thing. Okay, so like PCs have a BIOS. This is a PC, it's got a BIOS. This computer setup thing though lives on a partition on the hard disk. Now it's got this diagnostics disk thing, and this is where stuff goes wrong. So I've got a Gotek, and I've got a blank disk inserted. I actually made a blank disk image put it in there, and it's called blank. If I want to create one of these diagnostic disks, it says I need 1.44 meg disks, and that's all fine and happy. So I press OK, and it says it can't do it. It literally just says I'm trying to format a disk, and I can't format the disk. Now, as far as I can tell, I've set this Go Tech up properly. Like, it's not even trying to talk to it. Okay, this is literally what I mean. Like, it's now booting off the disk. It was not doing this yesterday at all. Here it is booting off this compact, quick restore disk, which is exactly what I wanted it to do. It would not do this yesterday. Right, well, since this now boots off disks, I'm going to try and get DOS installed on it properly. Great, so it installed DOS, but now it won't boot off this. So why is it not bootable? Or why is this stupid computer not boot off it? Is it that it looks for that partition first? Right, finally I'm getting somewhere. I eventually managed to wipe the compact flash card, but I discovered a weird thing about Linux. The card is not attached, but still, I can go into F-disk. Okay, we're in F-disk. Nothing attached. Yeah, SDC does not exist, but look, there's partition. I think it's died. So I was rebooting it to install that partition thing, and I turned it off, turned it back on, and now it doesn't do anything. Like, you turn it on. Oh, now it's working. Right, so I think there is an intermittent hardware problem with this as well. I tried to boot it before and it wouldn't. So I just unplugged it for 5 minutes and now it's fine again. Yeah, this is looking like it's going to get put in a box and ignored for another few years until I can be bothered trying to fix it properly. Assuming I feel like fixing it, given it's so awkward to use. Yeah, it didn't go too well, did it really? Got a bit annoyed at this machine. It seems to be kind of useless without its magic config partition, and I don't have the means to install that on a new drive without a working floppy and CD-ROM drive. So I gave up and went for a walk instead to clear my head. It's important to take a break really. Gave me time to realise the PC wasn't that useful for coding on, but I could at least make it run my code and demo the hardware, because I could put the things I wanted on the compact flash card and then just whack F5 like a maniac whilst Windows was trying to boot, drop into the command prompt and just run things off it. So I'd best build this thing then. The Covox speech thing is nothing more than a digital to analog converter, which sounds like a complex piece of equipment. So the hardware that we're trying to program is this thing that you're looking at on the screen. And there's not a lot to it really. Let's just skip through this video a bit. This is it. This is entirely the device really. It's a little box that you plug in your printer port and then it's got some speaker outputs on it. Inside it, there's barely anything. Like, I found this blog post which explains quite a lot about what's going on. But it is a thing that people have made before. There's a patent of it, so you can see the circuitry. It was a thing back in time where people would show how to make them. And look, here's another one. It's just a bunch of resistors. That's it, and a couple of capacitors. According to this blog, this is not the correct rating for the resistors, but I don't think it matters too much. I found this as well. So you can build it. You could get a proper PCB made and have one of your own. But what this was useful for is it tells me what I need, and there's a little picture of the board, and then also we've got the schematic as well, so I can see where things have to connect up to. So I'm going to make a combination of this and this. Hi-fi nerds get obsessive about DACs in their equipment. They have to have decent ones. Well, sorry audiophiles, you can kind of make one using a handful of resistors and it works okay-ish. It's surprisingly good, and I was able to find enough resistors of a close enough range to make the circuit. Honestly, I'm surprised it works at all, given I just rifled through my box of parts and went, these are not the right value, but they're close enough, and these ones are sort of close enough as well. It's probably fine. But it does work. Well, that's clearly wrong. I think the volume's too loud somewhere, so let's try again. There we go, that's actually pretty good. I was expecting some sort of horrific background noise from all these exposed connections. Or this long cable going to our main PC. Or some sort of horrific ground loop and humming madness. You know, I just didn't expect it to work. At best, I was expecting to show you this making recognisable but terrible sound and going, well, the idea's there, maybe I made it wrong, maybe it sounds this bad, I don't know, look, end of video, happy days. But no, it actually works, and it works really, really well. There's some curious audio artifacts present if you listen carefully, where the sound does sound a little bit digital, if that's a thing. I still don't know exactly why this works, or how a bunch of resistors can somehow combine an 8-bit digital signal, which is literally just 8 bits of binary coming out of a port, into something analog that a human understands as sound. Is an analog to digital converter the opposite? Like, could I run this in reverse and stick a microphone on it instead of a speaker and sample things coming out the printer port? You know, could I just read the printer port at 8 kHz and capture audio? Is it a two-way thing? This video was a lot of fun to make. Now I've become more familiar with how interrupts work, and DOS's insane memory layout is less of a mystery. I want to make something a bit more complex. Maybe a terminate and stay resident program, or play with boot sectors or something. I know logically the next thing I should be doing is looking at AdLib or Sound Blaster card programming, but I like to a bit of variety and mix things up. Maybe a TSR that plays fart noises when you press keys or something? I'm not going anywhere with this particularly, I just like exploring interesting low-level parts of how PCs used to work for the fun and challenge, really. And if you like this kind of thing, consider subscribing. You have watched the end of the video. The link's down the bottom, you know where the button is, everyone tells you where to click it. If you want to support the channel, I've got a Patreon, where you can get ad-free versions of videos and some random behind-the-scenes information as well. I've also got a website where I put extra content that isn't really always worth turning into a video, so go take a look at that if reading stuff is also your thing. But until then, I'll see you later. My autocue is now playing an advert for Temu. Wonderful. Apparently I can buy stuff for my kitchen on Temu. That sounds awful. Goodbye.